Okay, hopefully this is just going to be a review for those that either weren't here on the days and maybe let's just say you don't really understand probability or you just need a review, recap, whatever we need. This is an essential guide to what probability is as well as probability trees. So probability, the best way I can explain it is just going to be equal to a fraction. The fraction is going to be the number we want. So for a particular outcome, so I'm going to say for an outcome, this is going to be over the total number of outcomes. So when we think about the example of like any event, so let's say like if I roll a dice, say I just roll a dice, right? Let's say I just wanted to find the probability of me getting a 3, right? So in this example, I have to think about the definition of probability. So it's the number we want for an outcome. Now, we have to think about first, what is the total number of outcomes in a dice? So if we think about a dice, right? So if I draw like a dice right here, it has 1, maybe 2 here, maybe 3 here, something like that. If we think about a dice, we have to think about the total number of outcomes. Since it has 6 faces, I'm going to write, and this is a good way for us to memorize and just write down, at least like as a procedure, what to do for these problems. But we say that the whole number of outcomes is 6, right? There's 6 sides on the dice, so therefore it's going to be 6. And then the number we want, well, we want just to get a 3, right? So we have to focus on how many 3s are there on the dice. And in this case, it's just 1, right? This is a fair-sided dice, so in this case, it would be 3. Okay. That means that I'm just going to write the probability, I'm going to write as P, of getting 3 on a dice is going to equal to 1 over 6, right? I combined the two information to create my definition right here. Okay, let's say I did another example. Let's say I had a, let's say this time I had a 20-sided die. 20-sided, oops, I meant to say sided. 20-sided dice. Okay, so with a 20-sided dice, I want to find out, and this is numbered, let's just say only 1 through 10. So meaning that there's 2 of each number, right? So in this case, I'm going to ask, what is the probability of me getting, let's say, 1, 1, 2, and 3, right? I'm going to put or right here. So yeah, let's say what's the probability of me getting 1, 2, or 3 on this dice. So since it's 20-sided, we have to think about the number of total number of outcomes. So I'm going to say total number of outcomes. The total number of outcomes is just going to equal to 20, right? Because it's a 20-sided dice. But now I have to figure out the number we want. So notice again that I'm writing this procedure out to establish my probability definition. So the number we want is 1, 2, or 3. Notice how we can have 2 of each number, right? So in this case, what we can do is that we can say, well, since we want 2, 1, 2, or 3, each of them have 2, right? So I'm going to say 2 for the first one, plus 2 for the second, plus 2 for the third. So let's write that down. So this is for the first. This one is going to be for the second. And then this one is going to be for the third. When I add all of these up, this is just going to be equal to 6. So then notice that the probability of me getting 1, 2, or 3 on dice will equal to 6 out of 20. I can just leave it like this. I don't have to simplify. And this is basically just a small definition of probability. Later on, I'll be talking about like different ways that we can calculate probability, because in these cases that we're doing right now, these are just particular outcomes that may just happen once, right? So in this case, getting a 3 is just one event, same as 1, 2, or 3, but we'll later figure out, how to do this idea of or. Okay, there's one more thing that we can also talk about. This one is with a probability tree. So the best way I can describe a probability tree is basically a tree representing all the outcomes of events. Event or events, right? So what does it look like? Well, visually, it will look something like this. So notice that I can basically draw like this tree that has many branches. I'll say where each branch represents an outcome for an event. So let's just start off with basic stuff, right? So let's just say, as an example, I flipped a coin. So I have to think about the possible outcomes for this. Well, if I flip the coin, there are only two outcomes, right? So since there's only two outcomes, the probability tree that I'm going to draw out will have just these two outcomes. Okay, let's say in this case, as another example, I had the choice of getting, let's say, like for food, pizza, let's say wings, or soda, like a drink, right? That means that my outcomes are based on these three, so then my probability tree again would just involve these three outcomes. I can get either pizza, wings, or soda, right? So pizza, wings, and soda. I forgot to mention in this probability tree, since there's only two outcomes, I'm going to write heads or tails. Okay, but what happens if they involve multiple events? If you have multiple events, what you're going to do is that you're going to extend your tree to more branches. So let's take a look at this example, right? Let's say I'm going to flip two coins, right? So even prior to me thinking about the tree, let's just write down all the outcomes that I have. So what I'm going to say for this one, I'm going to say the total number of outcomes. I'm going to write them down, right? So the way I can think of it like this is that I have heads, and let's just say the second one is tails, right? So in this case, this is going to be the first one. This one's going to be the second. Okay, so if this is my first, my second, then the next one I can have is heads, then tails, right? Okay, but this is the case where the first one is going to be heads. What about the other one where the first one is going to be tails, right? So let's write that down. So let's say then we have tails first. Well, the second one can still be heads. And then likewise, this can be tails and tails. So therefore, we have 4 outcomes. So this is just me labeling just the amount of coins I can have. But now let's just draw the probability tree. And I'll keep this right here, right? So if I draw my probability tree, well, my probability tree, this is kind of the way I do it. So 1, I draw out my first event. So in this case, my first event is going to be the first coin, right? So for the first coin, how many outcomes does it have? Well, it has 2 outcomes, right? Heads or tails. So the way that my probability tree is going to look like is going to be this and this, just like what we did in the previous example. The second, for a multiple event, is then extend branches for next event. So what is my next event? Well, my next event is going to be the second coin, which also has 2 outcomes, right? So then what would this look like? Well, since I already started off with the first branch, the first part of the tree being this, so this is going to be the first coin, what I'm going to do is that I'm going to extend from these branches new branches, right? So from this heads, it's going to be heads and tails. Same thing for this tails, is going to be heads and tails. So notice this one is going to be the second coin, right? So I want you to notice. So notice that each column of the probability tree involves a different event. So if I look at the first branch, it's going to involve the first coin. But then if I think about the second coin, that is going to be a completely different event. Notice that these also create different outcomes, right? So when I have like heads and tails, it's very different from tails and heads. So notice the order does matter when I do these outcomes. Let me just do maybe 2 more examples of this. Then with that, we'll end this video. So let's give an example where I'm going to say, let's say I just wanted to do something for the day. Let's say there are 2 things, or let's just say that there are 2 weather conditions. If it is rainy, I stay inside or go for a swim, or if it's sunny, I run outside or take a nap. So let's think about this, right? So notice that my first event, so let's say I just try to draw a probability tree in this first case, right? So if I look at this, there's 2 weather conditions. So that's what my first event is. So I'm going to say my first event is the weather. So if I drew a probability tree, let's just say that I start off with 2 events, 2 outcomes. If it's going to be rainy or if it's going to be sunny. So let's think about what happens when it rains, right? I still have 2 options, right? I can either stay inside or I can go for a swim. So this leads to 2 more, right? Stay inside, go for a swim. Same thing happens when it's sunny, right? I notice I run outside or take a nap. That involves 2 more options. So I run outside or I take a nap. So notice that, again, this is going to be 4 total outcomes. I count the number of branches in my probability tree. Okay, let's do one more example. So let's say I'm going to, this time, a deli shop. And they have 3 sandwiches. Let's say they have 2 drinks, 2 sides, and let's say they have 2 drinks. So I'm going to say that this is going to be ham, chicken, and then I'm going to say cold cut, right? Sides would be chips. Chips. Let's say the second one would be pickles. I don't know. Let's think of a random side for a deli. And then for drinks, actually, I'm just going to say cookie. What am I doing? Cookie. And then for drinks, I'm going to say there's going to be Coke or Pepsi, right? So let's just draw a probability tree for this one, right? So if I had a probability tree to showcase like an order, let's think of it like this, right? You have to order all 3. So let's think about the first event. My first event is obviously going to choose the sandwich. So my first question is, how many outcomes are there? So in this case, if I look at how many outcomes I have, well, ham, chicken, and cold cut, right? So then I have 3. So that's how many I'm going to start off with. So 1, 2, 3. Next, I consider my next event. What's next after I order a sandwich, right? In this case, if I look at the 2 sides, that's my next event, right? So then now I'm going to look at how many outcomes, and I'm going to say there's 2 outcomes. So I know what I'm going to do is that I'm going to take this, I'm going to copy it, and then what I'm going to do is that I'm going to paste this tree branch, but then what I'm going to do is that I'm going to add 2 more outcomes, right? 1, 2, 1, 2, 1, 2. This is to showcase the new one. This is the new branch, right? Okay, there's one last thing that we have to do. Let's consider the third event, right? So third event, because there is 3 events that I have to choose a sandwich, a side, and then 2 drinks, right? So I'm going to say drinks, and then how many options do I have for choosing drinks? Well, it's 2 outcomes, right? So again, what we're going to do is that we're going to copy this branch. We're going to copy, I'm going to paste it right here. I'm going to extend it out just a little bit more. Then what I'm going to do is that I'm going to extend it to 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So notice this is what our probability tree will look like, where each one is going to be the different choices, right? I didn't label all of them, but then your job throughout like classworks and all that stuff is to label as briefly as you can. So like, for example, you can just say like ham, chicken, cold cut, and then chips, cookie. So like, for example, ham, chicken, cold cut, and see how I'm like labeling them. And then what you can do is that you can say cookie here, chips, and here you can say Coke, Pepsi. You can even shorten this one just by saying CO for cookie, and then CH for chips, right? So that's basically what you have to do for labeling probability trees. So just as a review, probability is going to be the way that we find this, which is going to be the number we want for an outcome over the total number of outcomes. I'm going to write S here. So that was an example of rolling a dice, or even a 20-sided dice. And then we also learned about a probability tree, where basically it represents all the outcomes of multiple events, or maybe just a single event. If I think about it, for just flipping a coin, it was just a single event, right? So then I draw 2 branches. But if I have to choose more, like multiple events, basically I can just see that each column represents an event. If I have multiple events, I'm going to have multiple columns, right? Here's the first column with the first coin right here. And then here's the second column with the second coin. I wrote here in the notice how each column of the probability tree involves an individual event. So this is an example of like the rainy or sunny, or even at the deli shop where we have even 3 events, and we can see we can keep on extending it out. And one thing to find out the total number of outcomes, I realized I didn't do here, is to multiply them, right? So when I have these multiple branches, what I can do is I can multiply the number of outcomes in each event. So in this example, right, so I have 3. This is going to be representing my sandwiches, times 2, my sides, times 2, which is 12, which is the total number of branches I have, right? So I'll just write that here. So sandwiches, sides, and then drinks. So notice how I'm multiplying the total number of outcomes I have in each event to get the total number when I combine all of them. So that's basically it for these 2. And then in the next one, I'm going to be talking about independent, dependent, and or as well as complement.